In this video, I'm going to cover single replacement reactions. Now this went along with your lab, and you should have picked up the worksheet from me, and this is question number 1. I don't have the worksheet printed out, so we're just going to handwrite it. Now, in a single replacement reaction, like you saw in lab, a reaction doesn't always occur. And so with a single replacement, you have to pay attention to this activity series right here. Before we get to that, the first thing you have to do is identify the metals in the problem. For us, it's always going to be the one that's by itself. This is a metal. And the first one here, that's going to be your other metal. Ag is silver. K is potassium. The only way that this reaction occurs is if the metal that is by itself is higher in reactivity. So this is where you're going to have to use your activity series chart. So you find silver on the activity chart. It's right here at the very bottom. The closer it is to the bottom, the less reactive it is. So silver is actually only more reactive than platinum and gold. And that's why our jewelry is made out of silver. Or a lot of our jewelry, it's only more reactive than 2 other ones. Now potassium is highly reactive. It's all the way up here. And that means that it's going to react a lot, which is why we don't make jewelry out of it. This one, for this reaction to occur, silver has to be higher in reactivity than potassium. Silver is not higher, it's lower, which means this is a no reaction. So you just place NR. Now I'm going to switch over really quick to number 2 on your problem. And it's Zn plus AgNO3. So we're going to look at number 2. All right. So in this particular problem, we have zinc as our metal that's by itself. And we have the first one here is our metal, which is silver. So we have silver and we have zinc. Remember, if you don't remember the name of these, that's okay. You look at your periodic table and you find them. So Ag has the name of silver, zinc is somewhere else right here, Zn. But for this to occur, the one that's by itself has to be higher, so we have to find them. Zinc is right here, and silver is right here. Zinc is higher in reactivity than silver. This reaction does occur. This is where it gets a little tricky for a single replacement. Your metals are going to switch places. That means Ag is going to be by itself, and zinc is now going to combine with NO3. Now, one thing that you don't have memorized, and that's okay, is that zinc, since it's a transition metal, it does have multiple charges, or it could, but zinc is special. It only has a +2 charge. And if you look at the back of your periodic table, NO3 has a -1 charge. So we're going to put NO3 up here with a -1. And remember, you have to write formulas. Now, I'm going to teach you a shortcut when you're writing formulas, and that is called a cross and drop method. The positive and negatives disappear. That's the biggest thing that people get wrong with the cross and drop. So don't forget, those just disappear. It's just magic. Just believe me. This 1 comes down here. This 2 comes down here outside the parentheses. That's your shortcut way of writing a formula. Now Zn, we don't write the ones. NO3 with a 2 outside. I'm going to put little spaces to balance, because this is all, like, you're practicing everything here. You're practicing predicting your products, writing formulas, and balancing. So now, just because I wrote all over this, I'm going to rewrite it really quick in order to balance it. Okay, I'm going to make a list. On this side, I have Zn, Ag, and I have NO3 on both sides, so I'm going to leave it together because it's a polyatomic. On this side, I have the same things. I'm going to put them in the same order as this one. And now I'm going to count. Zn has 1, Ag has 1, NO3 has 1. Feel free to move on if you're comfortable with balancing. Ag is 1, Zn is 1, NO3 I have 2. So the only thing that's unbalanced here is my NO3s currently. I go to the side that has less. I go to the blank that is in front of it. And there's only 1. Remember, there's kind of that invisible 1 right here. So what times 1 can give me that 2 that I need to match it with? And the correct answer is 2. But now this 2 distributes in just like math. So I have 2 Ags and I have 2 NO3s. I still only have 1 zinc. Okay, these numbers are no longer valid. Here are my new numbers. Well, now my NO3 is good, but my Ags are not. So I'm going to go to the side that has less, and I'm going to place a number here so that I can have 2. My magic number this time will be 2. This only affects Ag in this problem. I still only have 1 zinc, and I still have 2 NO3s. So now I'm balanced. This is the correct and final answer that will receive full credit on this worksheet. Give it a try. Come see me if you have questions.